So now we're going to discover the LCM of 18, 20, and 30 using prime factors. So we had two methods to determine the LCM. One was to create lists, and that's what we did previously. The second way is to multiply all prime factors of all the numbers in the set, removing repetition. Now, I am just going to take 18, 20, and 30. And you may have noticed I have broken up each number into the prime factors. Now, I'm going to create a box here. Why a box? I don't know. Because. And I need to ensure that I'm including all of the prime factors with no repetition. So I might make this box a little bit bigger. I know looking at 18, I need to have a 2, 3, and another 3. And then for 20, I need to have a 2, 2, and a 5. And then for 30, I need to have a 2, 3, and 5. So let me get started. I'm going to make sure I'm going to take all my factors of 18 and make sure that they're all in the box. So 2, 3, and 3. Since I have none of those factors in the box, there we have it. That number symbolizes 18. Now, when I look for 20, since 20 already has one factor of 2, I can sort of omit that. Now, I need to add a second factor of 2 in there, and I need to put a factor of 5 in there. So now 20 is represented by two factors of 2, which this box has, and a factor of 5. There is 20 in that box right now. And then I need to make sure that 30 is in that box. How do I make sure that 30 is in that box? I ask, what's in the box? Do we have a factor of 2? Yes, there's one factor of 2. There's also a factor of 3. And there's also a factor of 5. So 2 times 3 times 3 times 2 times 5 are all the prime factors of 18, 20, and 30 with all the repetition of factors removed. So I'm just going to reorganize this, that 2 times 2 times 3 times 3 times 5 is the lowest common multiple. Now, if we multiply this through, I believe 2 times 2 times 3 times 3 times 5. All right. So those two numbers here, 2 times 2 is 4. 3 times 3 is 9. So 4 times 9, well, 4 times 9 is 35, or 36 times 5. 36 times 5 is 180. And indeed, that's what we discovered earlier. So let's go do another example. 12 and 15. So if I take 12 and 15, what I'm going to do is break it up into their prime factors. Now I'm going to go a little bit faster if you don't mind, because 12 is really 4 times 3. And if you notice, I just wrote 2 times 2, which is 4, 4 times 3. 15 is 6 times 5. Incorrect. My apologies. 15 is 3 times 5. Very bad of me. I just almost made a very terrible mistake. So I'm just going to put my box. I'm going to make sure that all my prime factors of each number are going to be in that box. And I can remove repetition. So I'm going to maybe start with 15. 15 has two factors, 3 and 5. So I need to make sure that I put 12 in this box. So in order for 12 to be a multiple in this box, I need to make sure that I have a factor of 3. Oh, the box already has a factor of 3. However, I need to have two factors of 2, so I'm going to put that in there. So, and if we do this, what we get is 60. 2 times 2 times 3 times 5 is 60. Could create a list. Now, this one is a little bit scary to me. I'm not going to lie to you. But why don't I just do it for you? 28, 42, 63. So 28 is 4 times 7. 42 is 6 times 7. And 63 is 7 times 9. All right, that actually wasn't so bad. Now, for you to prime factor, you do you, but just notice what I did. Instead of saying 4, I know that 2 times 2 is 4. So I just wrote 2 times 2. Instead of saying 6, I know 2 is a prime number and 3 is a prime number. So I just, instead of saying 6, I just wrote 2 times 3. And 9 was 3 times 3, and those are both prime factors. Just so much easier and saves some trees. All right. So first things first, I'm going to put 42 in the box. Why 42? I'm just trying to demonstrate that order doesn't matter. I need a factor of 2 in there, and I need a factor of 3 in there, and I need a factor of 7. So I'm taking care of that factor, and that factor. And now I'm going to put 63 in the box. So I'm going to put the number that's in the box, a multiple of 63. In order for it to be a multiple of 63, I need to have 3 as a factor. I need to have a second 3 as a factor, which is not in the box. So I'm going to put a factor of 3, and I need a factor of 7. 7's already in the box. The prime factor 7 is in the box. So there we are. So what's the number in the box? That is the lowest common multiple of 42 times 63, whatever that might be. Now, 28. 28's curious because I need to have 7 as a factor. 7 is already in the box. I need a factor of 2. Yeah, correct. We have 1, 2 in the box. But I don't have a second factor of 2, so I better put it in there. And I actually don't know the answer to this, and I should have probably brought a calculator, but I know that it's 2 times 2 times 3 times 3 times 7. Whatever that might be. Yikes. Something tells me I should have probably done this ahead of time, but really that's 4 times 9, right? 4 times 9 is 36 times 7, and that is, taking old school, right? It's 252. And it is. There we have it. Well, I hope that you've learned something with lowest common multiple and greatest common factor. Now, did you know that I'm just going to talk not about the lesson anymore, but maybe something's bothering you why this works? Well, I'm going to did you know that I'm going to create a multiple of 28? Well, if I get a multiple of 28, I know that it has to have these factors. This is really 28. So is 252 a multiple of 28? Yeah. Now, I just put check marks above everything that is a factor of 28, or everything that's a prime factor of 28. And what am I missing? 6, right? I believe 6? Nope, incorrect. I'm missing the 3 and the 3. So that's 9. Did you know that 28 times 9 is 252? Anyways, I think that's a nice connection.